5.6 Exponential and logarithmic equations. We are going to learn to use the like base to solve the exponential equations, use logarithm to solve the exponential equations, and solve the logarithmic equations. Exponential equation is an equation with a variable in one of its exponents. So you'll see the unknown variable that locate on the degree power part. The logarithm equation is an equation with logarithmic expressions that contain a variable. So you'll see the unknown variable, it comes with the log form or the ln form. When you see the log, you know there's a base number, or if there's no base number, that means it's 10. When you see the ln, that means the base is a natural e value or e number. We use a one-to-one properties to solve for the exponential equation. If b power x equal b power y, b is not equal 1, b is not equal 0, then your x equal y. So we look at this example. The left-hand side has 4 to the power x plus 3. Right-hand side is a to the power 2x. I'm going to rewrite both sides has the same base number. So 4 is equivalent to 2 to the power 2. Now it has x plus 3 with a degree power. I can rewrite the number a into 2 to the power 3, and it has a 2x was there. Now since we rewrite both sides of the exponential equation has the same base number, I can simply to cross out the base value. Now we just solve for the degree power part. We distribute it here, so you get a 2x plus 6 equals 6x. Now combine like term, so you get a 4x equals 6, which is x equals 3 over 2. Use the logarithm to solve for the exponential equations. Solve the exponential equation 3 to the power x equals 5. Let me write down here. 3 to the power x equals 5. We want to solve for the x. So we raise up the logarithm on both sides. So I have the log here. I have the log here. You can raise up ln. The answer will be the same. Once I have the logarithm expression add on into it, we can start to apply with the property of the logarithm rule. So we can swim the x to the front. And keep in mind, without the log form there, if there's no log, you don't swim the power to the front. From the original question here, you cannot just bring the x to the front, rewrite into this way and say x equals 5 over 3. No, this is wrong. Unless you have the logarithm form there, then yes, you can swim the unknown x or the degree power to the front. That's the way it is. So now we can bring the x to the front of the x term, of the logarithm term. So you have x times log of 3 is equal log of 5. So you're solving for single x, you just simply to divide by log 3 on both sides. Keep in mind, your logarithm form is a numerical value. And then you just input the log 5 divided by log 3 into your calculate, and you will give you a number. So this one is the solution of your x. It's approximately equal 1.4650. Solve the logarithmic equation. One-to-one property of the logarithm. If log base b of x is equal log base b of y, then we can let the x equal y. So we try this one. We have the logarithm equation, log base 5 on both sides, so we can just simply to cross out the log base 5. Now we solve for 3x plus 2 equals 2x minus 3. So when I have the 2x bring to the right hand side and this 2 go to the right, it turns to the x equal -5. Now, when you have the logarithm equation, once you solve the unknown variable, you need to bring the number back to your logarithm form or logarithm expression here to see whether you will get a negative value here. If the outcome turns to a negative value, then that won't be a solution because we cannot have a negative x right next to the logarithm form. Alright, so we have to do the test every time when you solve for the unknown variable with your logarithmic equation. So this -5, when I plug in back to here, 3 multiplied by -5 plus 2, it gave me -13, which means we cannot take this solution. If you input the log base 5 of -13, the calculator will tell you it's undefined. So we don't take the value when you plug in back to this part here, it will turn to a negative value. So we have to discard this solution. So this won't be a solution, okay? We cannot take it. Even though when you substitute the -5 to the right hand side, you get a positive number. As long as there's a one value turn to a negative number, you have to discard the solution. Log 2x equal 25. We need to solve for x. Since there's no base here, that means it's 10, so I raise up 10. I raise up 10 to the both sides, and then this 10 will cross out with the log. Now you have 2x equal 10 to the power 25, and then you solve for x, divide by 2 to the both sides, and after that you input a value into it. So it approximately has 3.1623 multiplied with the 10 to the power 12. Because 10 to the power 25 is a huge number.